Hello everyone and welcome to Rational Science.
Hey guys.
As you can see, we're back.
I'm back.
Hans was on a secret mission, and we can't tell you anything about it because it's a secret mission, but all we can say is maybe, a little bit, we can say that he went on a mission to rescue a damsel in distress. Would that be pretty accurate? And enough. I gather you were quite successful at it as well. Okay, so...
we'll see, right?
Yeah. Okay, anyways, we're going to start out with our science critic. He made a 45-minute video criticizing the scientific method. Can you believe that?
The scientific method?
The scientific method, of course. But yeah, anybody's entitled to criticize it, right? The question is whether his criticisms have any validity. So let me set this up so that you can hear in his own words what he said, okay? And give me a second here, and we're ready, almost on our way. Here we go. The questions and issues to be addressed in this rebuttal are: is the universe irrational? Is it possible to observe a wave function? And does quantum mechanics propose the collision of wave functions?
Those are all things that have been observed, though. So are you saying that the universe is irrational? Although, to be fair, one of the things that I haven't heard is colliding wave functions. I have heard of collapsing wave functions and interfering wave functions, but never of colliding wave functions.
Okay, so two issues specifically. One is whether the universe is irrational, and the other one essentially, whether a wave function first can be observed and then whether they can collide. And so let's go with the first one. Here's a rundown, okay? And it goes like this. It's not that the universe is irrational. It's that the explanations people have for how the universe works that are irrational. And there I'm giving you some examples. The warpage of space-time or the geometry of space-time is gravity. You know, that's an irrational statement. You're saying that time has geometry. It's like saying that what's the geometry of love? What's the geometry of intelligence? What's the geometry of consciousness?
The shape of time? Is that what they're asking for?
Well, essentially that's what it is, because the physical interpretation that they're going to give is this bending of the canvas. The canvas represents space and time, and so essentially they're saying that they're warping time, and that's gravity. And it's okay if you want to do math and say, look, time goes slower or faster, that's one issue. But when you give a physical interpretation, you cannot say that time is warped, which is essentially what they have. And then the other's zero-D black hole. A lot of people are not aware that Chandrasekhar got a Nobel Prize for proving that a black hole is zero-dimensional. It collapses to zero size. And people don't like to hear that. They say, oh, what do you mean zero size? Yeah, that's exactly what Chandrasekhar got his Nobel Prize for. Okay? And so you have an object that is zero size, no volume, lots of mass, which is a concept, in this no volume, no size region, and it makes stars go around and pulls matter in. Yeah, sure. And then the other particles at two places at once, Big Bang creationism, and just an example there, faster than light, tachyons arriving from the future. What is all this? And so it's not that the universe is irrational. It's that these people are giving irrational explanations for how the universe works. The irrationality consists primarily in the movement of concepts. Okay, that's essentially the where the problem is.
Well, just using magic at all, I mean,
Not even magic, it's
things-
black magic.
Yeah, I mean, even magic can't make one thing be in two places at once. Like, no one understands it. You can't even make a program that makes sense of that. Like, nothing.
No, I guess not, right?
No.
Because if you
On
give
no level.
if you assign a name to one object in your program, I guess
As soon as you have two locations, two objects, like that's basically the definition of two things
Of
is
two.
because it has two locations.
yeah. So these are the things that you got to keep in mind, that they have irrational explanation. The universe, I'm sure, works rationally. I hope it does.
To a certain point, I mean,
But
it gets weird at the infinitesimal level. When you're at the fundamental level, it gets a little weird. But I guess at some point it kind of has to,
yeah,
but not that weird. I mean,
the way I look at it is Mother Nature, Father Universe, God, the devil, whoever you pray to, they don't know anything about concepts. Okay, we invented all concepts, so they work with objects. All they do is move objects from one place to another every day, primarily atoms. They work at the atomic level. So there's constant motion in the universe of what? Of atoms. That's it. That's all they understand. All these concepts, field, energy, mass, we've invented all that. Mother Nature and Father Universe, they know nothing about all that. They never went, like I like to say, Mother Nature never went to school. She knows nothing about math or arithmetic. Okay? That's us that give, all these relations. Anyways, second issue was whether you can have whether you can observe, first of all, a wave function, and then whether wave functions can collide. Can they actually collide? I put that in there, and this was what this fellow was criticizing, but he conceded at least that they interfere and that they collapse. And what he didn't understand is that there's no difference between interfere, collide, and collapse, because you're treating the wave function as a physical object in all three cases. That's the issue. Okay, so let's look at first issue is, can you even observe a wave function? And a wave function is what the second word says. It's a function. And what's a function? It's an equation, it's a number, it's an amount, it's a quantity. So you can't say that a function, that you're going to observe a function like floating out there in space. That's the issue. And if you can't observe it, first of all, then how can you imagine that it collapses, okay, or interferes with another wave function? I mean, what are we talking about? Is this physics? Is this... We have two wave functions that hit each other, that cross each other. What is this? And so, here first issue is, how do you observe numbers, floating around, moving, right? You can't do that. How do numbers collapse? What do you mean by a number collapsing? And what they're saying in quantum mechanics is the following. So let's understand this well so that we truly understand it, okay? They say that the wave function collapses to a point. Why? Because when they take the measurement, they take a measurement at a given spot, at a given point, and they say what happened was that this wave function, which is spread out throughout the universe, all the way to the edge of space-time, suddenly collapses, concentrates all of a sudden to a dot. And that dot is what they're going to call a particle. So let's look at what a particle is. This is from the Wikipedia. An idealization of particles heavily used in, I think they said mathematics, but maybe I was a little too liberal with my wording there, okay? But its defining feature is that what? It lacks spatial extension. Being dimensionless, it does not take up space. We're talking about nothing. Okay? Why? Because we're talking about a concept. They're talking about a number, a quantity. That's what a particle is. It says a particle is an appropriate representation of any object whenever its size, shape, and structure, physics, are irrelevant in a given context. So they're talking about, first, a wave function. What is a wave function? A bunch of vectors. What is a vector? It's got magnitude and direction. and you have a bunch of these arrows which represent magnitude and direction, and they're moving sideways, perpendicular to those directions, right? They're moving sideways, and suddenly all these vectors, numbers, right, they collapse to what they call a particle, which is what? No spatial volume, no dimensions, they take up no space.
Basically, they're just talking about a location with that this stores properties.
Exactly, that they measured. And so how do numbers physically interfere? Because forget about my colliding. I put the colliding in there. Forget about that if you want. No problem. That's my take. But how do they interfere and how do they collapse? What are we talking about? Are we saying that this equation collapses to a dot that, or a point, a ball, some kind?
What
is that what
it
you're saying?
that collapsed to?
Yeah, so colliding, interfere, and collapse in all three cases, whichever one you want to pick there, is a physical interpretation of what they measure. And this is where the problem comes in. Are we doing math or are we doing physics? If you want to do math, no problem. Measure all you want, give me the quantity, no problem. But when you say that the number collapses to a little ball, now we have a little bit of problem. That's where the problem is, okay? That we have a number collapsing to a ball, okay? And that's scary.
Well, sometimes, like what you said earlier about the warp space, could you say something like, you can calculate useful things with mathematics as if it were warp space. So you use the calculations for a warped canvas, but once you translate that into real life as a physical mechanism, it gets weird where we would be crushing the bottom of the earth on the surface of space-time.
Time.
So as an equation, it's useful, but as a physical interpretation, it makes absolutely no sense.
Right, and that's where the problem is. The problem is that the physical interpretations. And when people don't understand that, they say, okay, these people know all that math. They probably know what they're talking about. I don't understand that well, you know. No, the question is they don't have a physical interpretation that you can take to the bank.
They shouldn't even bother is the point.
Really, because a lot of them reject that as philosophy. And they say, well, that's philosophy, that's opinion. That's what
the particle looks like, who cares?
Right, it's like, we don't care about that. We don't give a real physical interpretation. We don't understand how all that works. We don't care about that because we're doing math, and we call that physics. No, physics is what Mother Nature does. You need to explain gravity, you need to explain magnetism, electricity, how the atom works. That's physics. But if you just measure and give me an amount and say this is how fast something is, this is how much it weighs or how much mass it has, now you're talking about numbers.
Yeah, that's just describing.
Yeah, and so you cannot translate that or automatically convert it into physics and say it's a ball that's, weighs space-time downwards or whatever. That's where the problem is. The transition from math to physics. Again, mathematical physics is a contradiction in terms. It's an oxymoron, okay? Because math is math, physics is physics. Never the twain shall meet. Okay, so here's a wave function, just so you see what it looks like, okay, what they're talking about when they say a wave function collapsed, or it interfaced, or it interfered, or collided, or whatever with another wave function. Here it is. That's what it looks like, that worm that you see there, okay? This is a fellow who says that all these particles, they form this wave function, and what are those particles? Well, they're values. So each one of those balls that you see there that form that worm, well, all those balls are also quantities. They're just talking about quantities, and more quantities, and that's what the two axes there are really indicating. This is just two axes and numbers on a Cartesian coordinate system. That's all we're looking at. Okay, so let's look at what really a wave function collapse is. Okay. Here it is, okay, and it's scary stuff, so if you're, this is not authorized for people under 18, so if you're under 18, please leave right now, okay? This is dangerous stuff. Here it is, okay? Here you have the wave moving before measurement, and then it collapses to a dot. That's a wave function collapse. If you never saw it, well, now you've seen it on this channel, okay? And so the question is, here you have a bunch of vectors. They're moving transversely with respect to the direction of each one of those vectors that represent magnitude and direction. So they have numbers that are moving. That's what you're staring at. They're represented by these arrows. And suddenly that whole bunch of numbers collapses to a ball.
Which it knows it's being watched. I never understood how physicists could just accept that as an axiom, like the electrons know they're being watched, that matter reacts differently if there are eyes on it. Like that they just accepted that, like, oh yeah, that happens.
Yeah, it's
in what world?
The physical interpretation is what is scary, because in, what was that, I think 1926, when this was determined by Werner Heisenberg and some of his pals there, Schrodinger and so on, what they did, they figured out things that they could not see. So they had the quantities, they had the measurements, but they could not see what they were measuring. In other words, the reaction was invisible or too swift. So what they did was put particles in there. But initially they started with classical particles because that's what they thought they were. And
Ball.
Classical particles are balls. This is a classical particle here. That's what it looks like. Okay, it's a ball. And then they said, well, it's not really a ball because it's actually another quantity that is at this location. And so, yeah, when you have that situation, you're dealing with quantities, but then the physical interpretation gets lost in translation. That's what happens. And you're saying that a number converts into a particle because they have to give you a physical interpretation because that's what the reporter is asking for. He says, well, I don't care about your numbers. I mean, what is it? What's the bottom line? What does this all mean? And the guy says, well, you know, the wave function collapsed. And so, whoa, what is that? Well, the number turned into another number, but it's a pointed number. It's like in that region. Okay. In fact, someone said it great for light. He said, light travels as a wave, but departs and arrives as a particle. That's the definition, or I guess the way of representing light. And what are they saying? Well, they're just saying nonsense. They're saying that departs as a particle, arrives as a particle, but in between it's a wave. So you don't really have balls traveling through the air. That's not the notion that they have. They represent it that way, but you saw it just a minute ago how the worm was made of all those little balls. So they still represent it that way, because how are they going to represent a wave if not with little tiny balls that represent, you know, that whole wavy thingy? Right? But then they say it departs as a ball, it arrives as a ball because that's what you can measure at a point, at a location. In between, it travels or extends as a wave. I mean, you know, like take, for instance, a wave of light, a photon, if you want to see it that way, a wave packet, however you want to see that. Does it travel or does it extend from the Andromeda galaxy, 2.2 million light years away, traveling at the speed of light? That's what the distance is, from there to the Milky Way. So does it extend from there to here, or does it travel? And if it travels, where does the wave begin? Where does the wave end? I mean, is it a little rowboat that's traveling through space without hitting anything? Is that how it is? Or does it extend? And if it extends, what is extending? Is it a bunch of vectors?
Well, you can tell they didn't try very hard on the physical interpretations,
Yeah,
because there always ends up with some limitations.
Yeah. Anyways, let's move on to the subject matter of today, which is philosophy.
Oh.
And we don't do philosophy in this channel.
Good, we're done. Bye, guys.
We do physics, but we have to distinguish philosophy from physics. And there's a lot of gray area because philosophy has a long tradition dating all the way at least till the Greeks, if not earlier, you know. And so the problem is that a lot of the subjects that belong strictly to physics fell under philosophy because the Greeks treated them under philosophy, specifically ontology. What is ontology? Well, it's the study of existence, to put it succinctly, okay? So, but where do I have to start? Well, I'm going to start a place that you might say, Bill, you're crazy. Why are you starting here? I'm going to start at my heroes, okay? and because it's got a little bit of context in what I'm going to say today. I'm going to start at who my heroes were when I was a kid, okay? And I'm talking about when I was about 15 years old, I got into communism, okay? And I was head over heels with communism, right? And these were my heroes, you know, Marx, Lenin, and Fidel Castro. And these heroes lasted in my heart for about 25 years.
You couldn't find uglier pictures of them?
And then what happened? Well, eventually, you know, I grew out of them. Okay, and I had other heroes, and these were two other heroes, Madeleine Murray O'Hair, who was the founder of American Atheists, and Carl Sagan, which was also an atheist. And I grew out of atheism as well, so these two stopped being my heroes, specifically Sagan, because Sagan just had nonsense, even in his extraterrestrial stuff, you know, the fact that he wanted to be in contact with another civilization and travel through the stars and etc. Well, all that was nonsense together with, you know, what he proposed, which was quantum mechanics and general relativity. So, you know, I have no fondness anymore of Mr. Sagan. I think he was an excellent teacher, but he was a lousy, we can call him physicist. If I call them mathematics, okay. Now,
did he actually do mathematics?
He did mathematics. Okay, I also had these two guys, which was Babe Ruth and Hank Aaron, and I grew out of them. They were my heroes when I was a kid. I was specifically collecting baseball cards, but they stopped being my heroes simply because I stopped paying attention to baseball and moved on to soccer. My point here is that, you know, we all have our heroes, especially when we're young. They could be your father and mother, for all we know. You know, they could be maybe your teacher, whoever. And sometimes we grow out of them, and we grow out of them mainly because we find something different in life, maybe through education, experience, whatever you want to call it. You know, you go through life, and then you start changing your mind about things. And I changed my mind about communism. I changed my mind about atheism. And about baseball. Okay, so
the most
all I'm
important
saying,
one.
yeah, keep that in mind today, okay, because I'm going to get back to that issue, okay. But let's start with, I'm going to start with one of the questions that someone made, okay, regarding philosophy. This is where we'll start. And he said, so to say here, philosophy is equal anthropology, biology, sociology, psychology. I'm a bit lost. And all I can say there is that, you know, there are aspects of anthropology that fall under physics and aspects which fall under philosophy. For this, we're going to need to define what philosophy is to know what aspects of a given discipline fall under one or the other. Okay? So before you reach a conclusion, say, what do you mean? Philosophy includes anthropology and biology and everything. No, let's wait till we have a definition, then we'll be able to pigeonhole these things and put them in the right place. Okay?
Did you tell them the fight we had 2 days ago? About
we always argue before we come here. Okay?
day one that I got here, we started just tearing the walls down about this topic.
He wanted to destroy my notion of philosophy. I would not let him.
No, I thought
I won that discussion, you know. I vote for my version of it. Anyways, here's another individual, and they came in there with an issue that essentially triggered the discussion today, okay? And says the following, she, referring to Ayn Rand as some people call her, I call Ayn Rand, was a philosopher, and the best one at that. Well, again, we won't know until we define the word philosophy. We won't know who a philosopher is until we define what philosophy is.
Hey, that's actually one of the questions. What is your definition of philosophy?
Well, you gotta have a little patience. Well, we'll get there. Okay. Continue. Says she was dealing, referring to Ayn Rand, right? She was dealing with ideas, morality, and politics, which pertain only to human life and choice. Yeah, the issue is that morality and politics are religion. They fall under religion. They don't fall under philosophy at all, as we will see today. Okay, once we define this word, this key word, okay, then we'll be able to put in the right cubbyhole that morality and Politics have nothing at all to do with philosophy. If that's what Ayn Rand did, she was giving you recommendations, she was giving you her opinions, and that's how we define religion. Opinions, beliefs, okay? Subjectivity, okay? Ayn Rand was explaining the universe. No, absolutely not. Even if she was, which she wasn't, okay? Even if she was, then she would be a physicist. Because if you explain the universe, meaning how the universe works, you are doing physics. You're not doing philosophy. Again, no such thing as ontology, no such thing as epistemology. There's only philosophy and physics. Okay, two branches, as we will see in a minute, okay? But this is what we're going to argue, okay? There's only two branches. One is physics, the other one's philosophy, okay? And if you are explaining how the universe works, you are squarely in the realm of physics, okay? So if you say, God made the universe, for example, you're not doing religion, you're not doing philosophy, you're doing physics. You're telling me how the universe came to be, and I want a mechanism for you to explain how God made the universe, okay? We need to see the mechanism, okay? Now, if you ask, why did God make the universe? Now you're talking about philosophy, because again, it's, as we will see, it deals with purposes and reasons.
Did you ever make the branch chart or the flow chart?
Yeah, we're going to see that in a minute. Anyways, to conscious entities. She was explaining the universe to conscious entities. Well, who else are you going to explain it to if not to conscious entities? I mean, do you explain? You can say that you explain it to a dog, okay? And a dog, sometimes we say the dog is conscious, but what we're saying when we use it in that context, we're saying it's alive. You know, it's still conscious, like, you know, maybe had an accident.
Meant sentient.
Yeah, right. And we should not confuse that with consciousness, you know, human consciousness. But if you don't explain it to a conscious individual, who else are you going to explain it to? I mean,
sleeping guy.
Yeah, he's not conscious.
Whispering into his dreams.
So yeah, it's got to be to a conscious person. Okay, so what's the problem? The problem is that no one has ever defined the word philosophy in the last 3,000 years, beginning with the Greeks and ending specifically with the Stanford Encyclopedia of what? Philosophy. Here we go with
someone tried.
Oh, you'll see in a minute. Okay, so, give me a second here, fella on the other side. Sometimes it happens.
You need a better...
Yeah. You got to grab it just right. Okay, anyways, this is from the dictionary.com, okay? What is philosophy according to dictionary, okay? This is our current definition. After 3,000 years, this is what we ended up with. The rational investigation of the truths. Truths are beliefs. You know, what's truth to you is a lie to me. Okay?
Oh boy, a lot of people would have a fight with that one.
I know they're going to have a fight with that. And principles of being, knowledge, or conduct. Well, knowledge is belief, again, and conduct could be, because now we're talking about behavior. But see, when you throw all these things in there, you say, well, it involves being and knowledge and conduct and behavior. When you throw everything in there just to cover all the bases, it's easier to tear your definition down. You got to limit your wording so it's not so broad, because when you make it so broad, then you can put in anything in there. You can say it deals with ontology.
Well, it becomes meaningless.
Well, one is that, but it's like God. If God means everything, then God means nothing. So you kind of have to, shorten the definition of God if you're going to use him in some rational way. If you say God is everything, well, then what is God? How can you use that? And then it's got two other definitions there. A particular system of thought, which is what most people understand by philosophy. It's his philosophy. Well, if that's the definition or the notion you have of philosophy, we have 8 billion philosophers on the planet, because everybody has a way of thinking and recommendations of how you should live and about politics and about religion. So if philosophy is just a way of thinking, it's a meaningless word. Okay, we all have a way of thinking. And then the other one is guidance in practical affairs. Those are recommendations. And again, it's like, hey, this is how you should live. This is who you should vote for, and that sort of thing. Well, those are opinions. And if it's opinions, and then when you say that you study philosophy at the university, what do you really mean? I mean, what are you studying? Are you studying recommendations? Hopefully you're studying something a little more serious than just an opinion, a recommendation to someone of how they should live, who they should vote for, or whatever.
Well, that's serious to a lot of people.
I'm sorry?
That's serious to a lot of people.
Yeah,
do take that seriously.
Well, yeah, I know, but my point
It's
is
not
that
objective, is it?
you're not going to study. This is what I'm saying. If you go to the university to study philosophy because you're going to take all these courses related to philosophy, you cannot say, well, I studied philosophy. What did you study? Well, I studied recommendations. I mean,
That is
hopefully,
what they
but everybody can have a recommendation, no problem there. But what are you going to do? Study recommendations? I mean,
That's what people do.
Yeah, I know, and this is the problem. This is why That's why I want to restrict the definition of philosophy to that first one there, to conduct. I'm going to just chop only that piece in there. That's what I'm going to be doing today. Okay, whether you like it or not.
Well, it turns it into an actual word because otherwise it has no meaning. If it has no borders, if philosophy covers all subjects, then what's the point of the word?
In fact, I'm going to get to that also. That's an important point that you made.
If it goes straight to behaviors and conduct, then you can. Then we know what we're talking about when we say philosophy. You're not talking about biology. You're not talking about chemistry. You're talking about purposes and reasons.
Right. Okay, and this is the definition from the Wikipedia. Love of wisdom. What it meant, I guess, from the Greeks or how it was translated from the Greek. Love of wisdom, what is that? I love to be wise. I mean, I love wise men. What does that mean? And then you see the word wisdom at the bottom. Also, I think from the Wikipedia. And is associated with attributes such as, and they give one, unbiased judgment. That's like
unbiased judgment is an oxymoron.
Yeah, it's an oxymoron because they're both opinions. Unbiased means that you're biased. That's what unbiased means.
No, judgment means you're unbiased.
Well, but both of them really, because unbiased means that, I mean, what is there that is unbiased? It's just the opposite of biased, which means it's the same thing. I mean, are we saying objective judgment? How can there be an objective judgment? So
that's definitely an oxymoron. Unbiased judgment. The whole point of judgment is one thing is better than the other. How do you know that if you're not biased?
Then you have self-knowledge. Knowledge is belief. I covered that in the past. A lot of people don't like that, but yeah, knowledge is belief. In fact, Plato defined it justified true belief, or that's how it was translated. That's what came to our days from Plato, the interpretation of Plato, that he was saying justified true belief. That's what knowledge is. And that last word, belief, means that knowledge is a synonym of belief. And I've gone through that in the past. A lot of people don't like it, but that's the bottom line. Until you can come up with a better mousetrap, that stays there.
You're saying belief and knowledge are the same.
When I know something, like I knew for a fact that communism was right, and I knew it for a fact. That lasted 25 years. Then my knowledge went away.
Well, that's a good point. I once had my brother and I once had a big discussion with friends of ours, and my brother really got a good one on them where he was talking about flat Earth. I think he was talking about Columbus going to the New World, where everyone knew that nothing was over there until we knew that something was over there. So it's like, how do we know or do we not know? Is it a belief? All that stuff.
Anyways, these definitions are not solid. Absolutely not. And if this is what we came up with after 3,000 years, we don't really have a good definition of philosophy. So if we're going to decide whether, for example, Ayn Rand or Aristotle were philosophers, let's first define philosophy in a rational, scientific manner, in a way that we can use it consistently, right? So that we can say, yeah, this guy was a philosopher, this guy was not. Because otherwise, we're all philosophers.
I'll give my 2 cents at the end.
Okay.
To not waste everyone's time.
That's when I shut the show and cut
the truth comes at the end.
Okay, so what is the problem? The problem is we have not defined, as I'm going to argue today, we have not defined philosophy in 3,000 years in a way that is scientific, in a way we can use it consistently, in a way that you can actually say that when you go to the university, you study philosophy and you come out being a philosopher, for example, right? Just an example. And so if we're going to say that Ayn Rand or Aristotle were philosophers, we had better know what that word means, okay? Okay, and just in case, here's the contrast with physics, which also has no definition today. We're defining philosophy and physics, okay, because those are the two words that we're going to be looking at or contrasting today. And what you look it up in the Wikipedia, it says physics, science that studies. Well, we already got a problem with studies because anybody can study and not know anything. You study for the test, you get a 0 on Friday. So, you know, what does study mean? Does a 2-year-old who studies, you know, his blocks or whatever, is he a scientist or a physicist?
Yep.
So studies matter, okay, you're close, okay, it's motion and behavior, yeah, okay, you're close again, but then we have a problem that says, through space and time. Well, we cannot travel through concepts, okay, try traveling through love, for example, okay, see if you can do that. No, you can't travel through space and time, so they shouldn't use that word through ever for space and time because space and time are not physical objects. And it says, and the related entities of energy and force. No, energy and force are not entities. Entities are objects, things. Those words are synonyms. And energy and force are something else. They're concepts. Okay, and so, no, physics, we do not study energy, and we do not study force, time, mass, or charge, or any of those concepts. Okay, we don't study love, we don't study intelligence, we don't study consciousness, none of those things, not in physics.
I think you can just stop it. We don't study.
And we don't study.
That explains a lot.
We never study. We never study. Okay, study.
Never read a book.
Anybody can study and not know anything.
These books are just for a show back here.
Okay, so let's get to the Stanford Encyclopedia Philosophy, and here you have it. I know this is going to shock some of you, but it's called the Stanford Encyclopedia Philosophy, probably the #1 reference site on the internet for philosophy. That's what it's called, the Encyclopedia of Philosophy. And this is the page. You can look it up. You don't have to believe me, but this is what you'll find. You'll find all these words are in alphabetical order, and what is missing is the word philosophy. You will not find the word philosophy defined in the Stanford Encyclopedia of Philosophy. Okay, so it gives you an idea how important these words are for philosophers, that they never define what philosophy is.
I think they just gave up. They're like, it's too hard.
Yeah.
Too many things in it.
But then there's another notion that people have of what philosophy is, okay? And they call it the mother of all sciences. Oh. And this is an analysis that a fellow did in Quora. I liked it, so I'm going to put it up here. It says, the question was, why is philosophy the mother of all science? And this fellow answers, philosophy is not a science at all. Okay, according to today, okay, to what we have today, the definition or the notion we have. The connection between science and philosophy is historical, not conceptual. At one time, the natural sciences were considered a branch of philosophy called natural philosophy. The idea that natural philosophy was somehow replaced by science is total BS. Natural philosophy is simply what natural sciences used to be called. Philosophy could be considered the mother of all science for historical reasons, but not for scientific or philosophical ones under modern understandings of these terms. Okay, so this notion that people have that, philosophy is the mother of all science, it precedes science because you have to do some kind of thinking. Well, again, it's because they never defined the word philosophy. First of all, it's a historical issue, and it's very poetic. It does not mean that it's rational, that it has any foundation whatsoever. Okay, so when people say that philosophy is the mother of all sciences, they're talking poetry. That's it. Okay, they're not talking any sensible thing. Okay, so what is philosophy? Let's get to it. And for this, we have to define science first because we're going to include philosophy under science. It's one of the two branches of science, okay?
This is according to you.
Yeah, this is according to this site, okay? Science, rational explanations. Very short definition. The longer you make, the easier it is to tear apart. So never define words, crucial words, the foundations of, in this case, science, with lots of words. The more words you put in there, the easier it's going to be to tear apart because there's going to be exceptions. That's the problem. So what is physics? One of the branches. Well, physics is rational explanations of phenomena. And what is, of things that occur, right? Okay. And then philosophy is the rational explanations of behaviors. Okay, that's how we're going to divide this. We're going to limit it just to behaviors. In the case of physics, we have causes and mechanisms, and in the case of philosophy, we have reasons and purposes why someone does something. Okay, and again, the bread and butter of physics is the object. You need to have objects, and the bread and butter of philosophy, you could say, is the concept. Okay, in general terms. So that's how we're going to branch these things out. We're going to define them very specifically so that we can use them consistently. Okay, that's where I'm headed. Okay, so if those are the definitions, we've never had philosophers on planet Earth. Okay,
Not one.
not one, because what were they supposed to do? They were supposed to explain behaviors. Now, I can't say we've never had any philosophers. I'm saying that all the traditional philosophers were not philosophers. Maybe a psychologist is a philosopher because he's got to explain, a behavior of maybe one of his patients,
I like
or a
that.
psychiatrist or whatever. So he's a true philosopher, but they're not considered philosophers. The philosophers are those people who talk about the existence and all this other stuff, which has nothing to do with philosophy and has all to do with physics.
Yeah.
Okay, and so all these people that we have here, okay, that I put up the other day, Plato, Aristotle, all the Greeks in general, okay, all the way to Ayn Rand and Sartre, John Paul Sartre, and Thomas Kuhn. None of these were philosophers. They did not do philosophy because they never explained anything. I like to do an analogy in saying that this is essentially the Mary Poppins version, okay, and there's a part in Mary Poppins where Mr. Banks, the banker, he says, will you be good enough to explain all this, talking to Mary Poppins? And she says, first of all, I would like to make one thing perfectly clear. And Mr. Banks says, yes? And Mary Poppins says, I never explain anything. And that essentially synthesizes, okay, what we have today. We don't have explanations either from physics or from philosophy. Okay, so that's why I'm saying that we had no philosophers, at least the traditional ones. That's what I'm really referring to. Well, again, and I could make an exception and say that psychologists and maybe psychiatrists, people like that, they are the true, genuine philosophers because they try to explain behavior. Could be also a veterinarian. Looks at an animal, says the reason this animal behaved this way and that way, and he gives a reason. Then is also a philosopher. Okay, in that context. That's where I'm going to limit philosophy. One portion of the broad notion that we have today of philosophy. Okay, so I'm going to chop it off there. And under that definition, we can reject traditional philosophers, including Ayn Rand. She was not a philosopher. Now, this person gave one example, and I'm going to analyze that example to show you also why we need to separate physics from philosophy. And this person said, objects exist independent of consciousness, is what she says, meaning Ayn Rand. Okay? And no, that's not what she said. That's not what Ayn Rand said at all. Okay, I want to make sure that people understand that. Ayn Rand did not say that. What did Ayn Rand say? She said the following, okay? She said, to exist is to be something. And I'm saying, no, she missed something there. It's something plus location. That's what exist means, because the word exist belongs exclusively to physics and not at all to philosophy. When you have philosophers who venture into physics, not knowing that they crossed the line and they still think they're doing philosophy, well, we have a problem, because we need to chop off the word philosophy so it does not encroach on physics and say, well, we're doing ontology. No such monster. You either do physics, like Mr. Rutherford says, or you do stamp collecting, okay? And so the word exist belongs exclusively to physics, and it's defined as something plus location. It's got to have location. But here's what Ayn used to say. This is out of her books, okay? Perceive. She talked about perceiving things, entities, okay? Again, not. Awareness of entities, sight and touch. Again, we remove the observer in science, especially in physics. We don't use the observer. We kill the witness, mafia style. Okay, no one is allowed to testify. Something exists which one, what? Perceives. Absolutely not. Existence and consciousness are axioms you cannot escape. No, consciousness has nothing at all to do with existence. Not at all. We don't care what you perceive. You could be drunk. You could be on steroids, whatever, up your head, you know. So, no, we don't use consciousness at all for existence. A thing is itself. Existence is identity. Well, you can say that A is A, meaning ball is a ball, no problem. But that doesn't define existence. Existence, you need location as well. That's what she missed. And something needs sight and or touch. Absolutely not. We don't use the observer, we don't use sight, we don't use touch, we don't use any of the senses except common sense. The least common of all senses. And again, she talked about perceiving entities. So no, the problem with Ayn Rand, she introduced the observer, and when she does that, she goes into religion. She goes into subjectivity and not into physics. Exist belongs exclusively to physics. That word belongs there and there alone. And so here's the definition of exist so that we can compare it against what Ayn Rand proposed. Exist is physical presence. Very short definition. We keep it as short as we can. What is physical? Object. What is presence? Location. Okay, what is an object? That which has shape. What is location? The set of distances to all other objects that exist. Okay, that are there. And so if God wants to exist, first God has to be an object, a thing. He can't be a concept. You can't say God is love, God is spirit. No, God has to be an object. So you can say God is a man. Looks like a man, arms, head, whatever, you know. Okay, then we have an object. So far, so good, but you're not done. God has to have distance with respect to everything, every atom in the universe.
That
Okay?
means no matter what, something that exists has to be able to answer the question, how far is it from me?
No, because how far is a question of math. This is all qualitative.
That has an answer. It's not.
Yeah, but this is the answer. This is
Like what number it is doesn't matter. I'm just saying it's a binary. It either has some distance to me or it doesn't.
Yeah, for that, again, we define distance as separation. There is a separation between my chest and God's chest, one, and then there's a line of direction between me and God. God can hide in any dimension he wants. He can go to 26th dimension of string theory, okay? We don't care. There's got to be a straight line of direction from me to him wherever he wishes to hide. If we can't do that, he does not exist by definition because he does not have location. Okay, that's the way we look at it. So it's got to have two things. It's got to be an object. It's got to have location. What is location? The set of distances to all atoms in the universe, okay, in existence. Okay, so here are the foundations of physics, okay, to separate from philosophy. These are words that belong exclusively to physics and not at all to philosophy. Anyone touching these words, whether they know it or not, they cross the line into physics. Okay, these are the foundations of physics. And I haven't covered every word, but just the most important ones. Here they go. Object, distance, location, motion, exist, and space. Those words form the foundations of physics. They have nothing at all to do with philosophy. We do not deal with entities, which is what Ayn Rand tried to define. She dealt with existence. Not only did she misdefine it because she was not into physics, didn't realize that she crossed the line into physics. And yeah, hopefully she tried to explain to a conscious person. That doesn't change anything. Okay? So these words belong exclusively to physics. They do not belong to philosophy at all. Okay, so anyone touching these words, whether they know it or not, they cross the line into physics and they are no longer a philosopher, or they're not doing philosophy. Okay, and final issue before my son here kills me, okay, here we have the fallacies. If you're going to define, the word philosophy, first of all, keep it short, very brief. That's my strong recommendation. The more words you put in there, the more ifs, ands, and buts, the more bases you try to cover, the worse it is.
It could be complicated.
Yeah, well, the more complicated you make it, the easier it's going to be to tear down for someone who wants to challenge you. Okay, keep that in mind. That's my recommendation.
Or a friendlier way to say it is the harder it is to understand.
Also, yeah. But these are the fallacies. You can't use any of these fallacies because those are not valid arguments to defend your definition. They're the fallacies of authority, of democracy, and of tradition. What is authority? Well, my teacher told me. This is what I learned in college or in high school or
She knows a lot of things, so she must have done that too.
Yeah, I mean, the fact that this is how you were raised, or maybe your parents told you this, and you say, well, I think my folks were right,
Well,
again,
a better way to say
you can't use it like that. You can't use it as an argument. That's what I'm saying.
Well, the better way to say it is they were right about the first 9 things. Why wouldn't they be right about the 10th one?
Yeah, but again, I'm sure Marx was very right about communism, but I kind of got away from that. Fallacy of democracy. The fact that everybody on Earth votes for the flat Earth does not make it so. Okay, so the fact that more people raise their arms and say, oh, mathematical physics is right, it doesn't make it so. That's
2 plus 2 equals 5. Doesn't matter how many people.
Vote for it. You can vote. You could be in an asylum, and all the crazy people, they vote for whatever, and you say, well, but you're all crazy. Yeah, but you're a majority, and so what are you going to do? And then the tradition, the fact that we've always done it that way since the days of the Greeks. That's what philosophy has always been. You're going to change that now, Bill? And what I can tell you there is the following: all these words that I mentioned earlier, they're up for grabs. No one has ever defined them scientifically in the history of life on Earth. And so they're up for grabs. You can define any of them.
Satisfaction.
It's easier to tear them apart.
Yeah.
So if you can tear them apart, then I don't care if they have tradition. I don't care if they have democracy behind them or what was the authority. It doesn't make it so. So these words are up for grabs because no one has really defined them scientifically. Everybody uses the definition they find in the ordinary dictionary, which is of no use if you bring them into physics, because now you're going to run into trouble communicating in a rational environment. Okay, that's why these words need new definitions. So these words are up for grabs to say, Bill, but we've had a long tradition and everybody votes for them, and this is what they taught me in college and high school. These are irrelevant arguments. These are not arguments that you can use. They're easy to tear apart. Okay? I pass the microphone to you if you want to say anything. Yep. Okay, that's over. Now.
I mean, I put in one of the... Okay, so we got a few questions here. Let's start off with your definition of philosopher. I'm sure you hit it at some point, but just to reiterate.
Okay, reiterate philosopher. Let's go with philosophy. This is what a person who does philosophy would be a philosopher. What is philosophy? Philosophy is the explanation. Remember, it's got to be a rational explanation of what? In this case, of purposes and reasons, of behaviors. So, and I'll give you an example, okay? Napoleon.
Can we get a different example for once? It's always Napoleon and Waterloo.
It's always Napoleon and Waterloo.
Why did he go to Waterloo? How about that? Let's actually answer the question.
Why did he go to Waterloo? I mean, he went to fight a battle, and you have different theories. You have different explanations. One guy says, well, he went to make money. The other guy says he wanted to be famous. He wanted to leave his legacy in the history book. You can have different explanations. Okay, rational explanations, and people listen to one, listen to the other, and then people choose. Choosing is religion. You choose one theory over another. That's fine. But this is what philosophy is. Okay. Okay.
We had another one.
Yeah.
I didn't quite understand it, but and we'll get to them.
Okay.
Is a ruler 2 things because it measures length?
2 things? What do you mean 2 things?
2 things. That was the question. I'm guessing since you can pick out 2 points on a ruler. Would that count as 2 different things?
Are they talking about concepts? Because concepts is a word that invokes or embodies 2 objects. I don't know if that is referring to that. A ruler is a physical object. That's what it is. You point and say ruler. But if you're going to compare something and you're going to say the front end of the ruler against the back end of the ruler, you're talking about 2 points. You're not talking about the ruler. You're talking about the ends of the ruler, and you're treating them as separate objects. And now you have a relation. So now you're talking about a concept. So the ruler is a physical object. The 2 endpoints of a ruler and you're making a relation between them. Then you're talking about a concept. Any motion, by the way, any type of motion is a concept, known as a dynamic concept, because you're going to have two locations, or a comparison against another object that's moving, or whatever. Or you're going to compare the motion, the location of the object with respect to a starting point. So any motion is always a concept and always a dynamic concept.
Does that mean when you're, for example, in the case of the ruler, you can cut out a shape, any shape you want out of the ruler? In this case, we're cutting out one end of the ruler and cutting out a different end of the ruler and treating those two cutouts as separate objects.
Yeah,
so it's not the ruler
let's look at another word. This is contextual, right? Direction. Direction, you can only have direction if you have tacitly, implicitly, right, 2 points. So your direction implies or embodies two objects. Okay, you can't have direction with just a single point. Okay, you need to have by the concept itself, the conceptual, you need to have two objects for direction.
This is a short one.
Okay.
Are behaviors things?
No, of course not.
What's the difference between a behavior and a thing, then?
That which has shape is a thing.
Okay.
And behavior, don't confuse it with pattern. Okay, behavior and pattern. People use the word pattern like he's got a pattern of behavior, like you've got a pattern of how you behave or your comportment or whatever. That's different. We're talking about pattern like when you look at an ice or I don't know, for example, a piece of snow. It's got that little typical pattern. Well, that's not the same thing as pattern of behavior. Okay, so let's separate the word pattern from one and the other, which is probably the context that this person is raising it here.
Because usually when you're explaining someone's behavior, you're using a pattern of behavior.
Right.
Something you've seen before.
Right, but we're not drawing anything. We're saying that we're using the word pattern only in the sense that this is the way the guy behaves. We call that a pattern. That's different than the pattern of an ice cube or whatever, a snowflake.
You might have to redefine philosophy and physics one more time because is philosophy a superset, or this is more of a statement, if philosophy is a superset of physics according to your definitions?
Superset.
Philosophy is superordinate to physics. Physics would be a branch.
Subordinate,
yeah,
you mean?
Physics would be a branch of philosophy according to your definitions.
Why? No, I think I made it clear, but let's clarify that just in case. Science is the big one, okay? We're going to put philosophy and physics under science. Okay, that's what we're going to do here, okay? It doesn't mean you have to agree, but in science, we do not agree and we do not agree to disagree. There's no such thing as agreement in science. In science, we have to take shield and sword, get inside the ring, and fight for our definition.
Understand each other.
One person can remain standing. Only one definition remains standing. We can't have two definitions for exist. We can't have two definitions for the word object, location, etc. Only one definition remains standing.
Or else we won't understand each other.
Right, because then we're talking across purposes. But so what was the issue again?
Is philosophy superordinate to physics?
Right. Yeah, what you have is science, and then on that you have two branches. One is physics that deals with mechanisms and causes, and philosophy, which deals with purposes and reasons. Why someone does something. It has nothing at all to do with the shape.
Let's clarify. We're talking about people.
Well, not necessarily. It could be an animal also.
But living things. Or
yeah, let me. I think you can exclude.
So why a rock roll down the hill?
You're going to exclude plants and rocks rolling down a hill, or why the little toy airplane, or the kite flew. That's physics. You can't say why in the sense of. You can say why in the sense of cause, but not in the sense of purpose. When you say why did he fly a kite, then you're talking about the person. Okay?
Why did you exclude plants?
Because you're talking about purpose, and I can't imagine
if it's a living being.
You could say that, I think that's physics now, because if you're going to say that the plant behaves this and that way because the sun or whatever is in contact with it, or it reacts to the sun, now you're talking about physics. Well, I can't imagine a plant having a purpose or a reason.
Well, okay, but if we're going to go down that route, then there's people who believe in determinism, and according to determinism, everything would fall under physics. because it would just be a chain of events of atoms bumping into each other,
Yeah, and that,
explaining every behavior as well.
in fact, when you look at determinism versus free will is more like philosophy and determinism more like physics. Okay, because determinism, we're saying, look, everything's already cut out.
Everything's physics.
Every atom is out there, you know, and it happens in a certain way, like Mr. Laplace said a couple centuries ago. Except, you know, you have to focus, or you have to separate what each atom does, okay, from what the atoms produce, like the atoms in your brain, the ones that form the cells, the thinking part. You know, that's not physics. The physics is that you create the thought somehow, right? Electrochemical processes, that part's physics. But the thought itself, you know, why you think this way or that way, why you took this decision instead of another, that part falls under philosophy. Because now you're talking about behavior, purposes.
This one comes from me.
Uh-oh.
Yeah, here we go. We're going for the. Actually, let's do this.
Okay,
one first. This one's easier.
The show is over, folks.
Killing the witness. You often talk about killing the witness, but you also often use God's eyes or similar phrases when you're explaining your things. Like, let's imagine. When you use the word imagine, you're implicitly putting in an observer always. And that tends to confuse people. How do you...
It tends to confuse people. That's true, because people confuse the... it's a thought experiment, remember, because you're thinking about you thinking or about someone else thinking about God doing his thinking. So you're kind of putting words in God's mind, so to speak.
You're putting a person there.
You're putting a person there, a third person, you know, so you're going to explain a phenomenon, a mechanism, but you put God in there and saying, you know, for example, that he created the universe. But again, we have to separate what's going on in God's mind from what comes out of his magic wand, the process, the mechanism that comes, you know, here the magic wand, and we have a magic wand. And so you have to separate the mechanism of how he created the universe from the why did he do it, what was his purpose, what was his reasoning. Okay, so...
Yeah, this is kind of what I was going at. Someone says here, you could apply philosophy to plants. For instance, fruit trees want its fruits to be eaten since it will then propagate its species, since the poop seeds will give more fruit trees in the future.
The question is that a question of physics, or, I mean, does the plant do it consciously, or is it that this is how it evolved? You know, like you have these plants that eat insects, right? Carnivorous plants.
Flytraps.
Carnivorous plants are known as, you know. And so the issue is, does the plant do it consciously? Does it say, oh, I'm going to trap that fly? Or is this a mechanism that evolved over time, a mechanism against the way things developed in evolution, where, you know, maybe, I'll just give an example, the fly just fell in there, tickled something in there that triggered some spontaneous reaction, and this thing closed in, and they say, hey, I like the way I'm feeding myself. And obviously they didn't do that, but it's just a mechanism, it's just a trigger trap. It's like, you know, when you set a trap for a mouse, right? You set a trap, the trap is not thinking. As soon as the mouse steps on it, the trap hit, you're thinking, because you want to catch the mouse. You have a purpose for that trap, but the trap itself has no, it's just a mechanism.
Well, actually, there is a form of thought that would say that any form of reaction is a type of consciousness. When you hit a bell and it goes bing, that's a very basic form of consciousness. They're saying the bell is actually conscious because it gives that reaction, and our sentience is just a high level order of reaction. We have just very complex reactions.
So you're saying I hit a drum, right?
Yeah.
And it goes thump.
That would count as a low level consciousness. Because it's a reaction.
I mean, I think you're going to get into a lot of trouble with it. You're going to get into a lot of trouble if you start defining things that way. Every thump,
every
ring, every whatever is...
It's like Pocahontas. The rocks have consciousness.
A beginning of consciousness, you know, or of some kind of purpose.
Well, no, but this goes to the point where the more you delve into it, either you say everything has consciousness, even the bells and the rocks, or nothing does, and it's all deterministic. and we're all just a chain reaction of atoms. But that gets into weird.
Well, one of the biggest things to keep in that train of thought is how life developed. You know, here you have objects, atoms, right? And they form these DNA strings, right? And somehow that morphed into something that crawled out of the ocean.
Animate inanimates.
Yeah, and so you went from physics to something that's thinking, or that has a CPU, central processing unit, that controls each one of the compartments of a cell, which apparently is the unit of life. The unit of life is the cell, whether plant or animal, the unit is the cell. But what is a cell? A cell is a compartmentalized entity, and you can say it has thinking, it has, I don't know if it has purpose exactly there, if that arises later, but certainly it has some kind of thinking because it's organized in such a way that it knows that it's got to move this thing, that thing there, and it controls it all from a central processing unit. And how did all these atoms, which are just atoms, I mean, we're atoms also. And I mean, if you cut us into little pieces, you eventually end up with a bunch of little marbles known as atoms, right? And so all these things put together make something that now takes a life
and is very interested in keeping moving for some reason. Like, we really don't want to die. We really like moving.
Speak for yourself.
Okay, I kept the best question for last. This one's the one that I kept to tear down everything you talked about.
Okay.
So if you have a question, little Timmy comes along and has a question. Why does the category of the question matter? Whether it's philosophy, religion, or physics. Why does that matter at all to this question?
Well, I think we need to separate in order to have a rational conversation. If I'm going to explain a mechanism, that should not be confused with a reason. That's what I'm saying. And so somehow I have to separate those two, reason or purpose, from mechanism and cause.
Are you saying we have to find out what they're asking?
No, what I'm saying is, if the person is asking a question, right, the first thing I need to do is pigeonhole it to find out, are you asking a question of reason and purpose? You know, why God created the universe? If he had a headache maybe that day, that's one issue. Or are you talking, how did he do it? What was the mechanism? So first of all, I need to, again, pigeonhole it. You know, I need to put it in the right cubby hole.
But that's
right?
just knowing what they're asking.
No, because if I'm going to if I give you an explanation of mechanism, because that's what you're asking, that's what you want to understand, right? Then I give you a mechanism. But if you say, why did you do it? Oh, that's a different story. Now you want a different type of question answered. And so all I'm saying is all questions can be divided in those two categories. We call one physics, the other one philosophy. Now, a lot of people are going to say, again, Bill, I don't like your definition of philosophy, maybe even of physics. No problem. You don't have to agree to my definition. All I'm saying is, the way it works in science, you get inside the ring and fight for your definition. You cannot say that's how we always done it. Tradition. That's how my teacher taught me. That's what everybody votes for. None of those are valid arguments. You need to get inside the ring, get a definition that we can use consistently.
Well, I'd just take it a step further and say there is no purpose to defining philosophy or science, because that never answers a question that anyone needs answered. If Timmy has a question, it doesn't matter if you call it philosophy, banana, or science. Answer the kid's question.
Well, I need to know what he wants to know.
Yeah, but it doesn't matter what category of
it turns out that when answering the question of magnetism, Richard Feynman, you can look it up on YouTube.
Yeah.
He said, well, "What is it that you want to know?" When the reporter says, "How does a magnet attract another?"
That's a good question.
He said, "Well, what is it that you want to know?"
Yeah,
that's
what are you actually asking?
He's answering with a question. And that's true. Okay, let me get to the Moonies, okay?
Oh, we're still going.
Yeah, we're going a little bit. I don't want to lose the Moonies because there were lots of questions on the Moonies, but we're going to go relatively quickly. Who are the Moonies?
Running out of paper.
Okay, the Moonies. Who are the Moonies? Moonies are people who believe that we did not land on the moon. Okay, so they don't make that assumption. They don't accept it.
Is that what they're called?
Yeah, well, I call it in this channel. Okay, so here's a couple of issues that these people raised, not only with respect to the moon, but with respect to the ISS, which I raised as an issue, and a couple others like the Challenger and the Columbia disasters. Here's the question. One fellow just says, "We didn't go, Bill. that's you haven't said anything. You just given me your opinion. Unless you fill that up with a little more, we have nothing.
Why you even address it then?
Well, no, but a lot of people make comments like that, and I mean, I think some of these people are just wasting their time. Why even write 4 words when you said absolutely nothing? You just gave an opinion. You just voted. That's all you did. That's religion. Then another fellow says, "Why on earth do you still believe in a retroreflector on the moon?" Well, the first thing you have to understand is that you do not need humans. In this case, Apollo 14 and 15, where they placed, allegedly, for those who believe we went to the moon, that's when they placed the retroreflector on the moon, okay? But the Russians put a retroreflector on the moon without ever putting a human on the moon, a Russian, on the moon. They did it all artificially with, robots. So the first thing you have to understand, you do not need a human to go in there and put that little device on the moon, okay? And so the only question there is, did we ever send a rocket to the moon? Any probe or anything? That's the issue, okay? So forget about humans if you're thinking about a human placing it there. That's all I'm saying here. And then the other fellow said, with technology being what it is today, holographic projections could be quite convincing on a scale we are unaware exists. Okay, this guy's just putting things beyond our reach, saying, well, we don't know all the things that they have out there, so maybe it happened, maybe it did not. He's referring to the ISS. He's saying that it could be a hologram.
They're so good at faking things, we'll never know anything is true.
Yeah, so
that guy just gave up.
Yeah, well, yeah, that's all they're doing. They're putting it beyond the reach. It's like saying, well, we don't know everything, and so by doing so, they're just putting it beyond the reach. Whatever you answer, he's going to say, well, we don't know everything.
Well, he just gave up.
Yeah, that's all he's saying. But all I'm saying here is that thing up there, hopefully it's not a hologram. I mean, if you can't tell the difference between a hologram and the real device when you focus, with your binoculars, okay? These are a pair of binoculars, okay? I encourage people to buy them, or a telescope, and you'll see the ISS up there with your own eyes. You do not have to believe it's there, or you'll see some of the arguments people made on whether the ISS is up there to begin with.
Why would they,
I mean,
why would they spend so much money to even make a hologram? Assuming it were a hologram, you know how hard it would be to and for no reason, we just have a hologram going around Earth.
No,
just to trick one dude.
Imagine what that is. Hologram would be focused from the ground, right? Some kind of laser or whatever, and you focus it at the sky. But imagine now that from there, going all around the Earth.
Yeah.
Come on, man.
Or maybe
maybe it's from a satellite.
No, because they don't believe in satellites.
Right, I know, that's what I mean. Maybe it's from a satellite.
So it's just a car that's going really fast, or a plane. Like, why would they bother?
Well, they say they're trying to fool us. All these people who govern the world, they're trying to.
Oz has a lot of work to do.
Yeah. Anyways, one individual says, "What does the ISS existing have to do with the moon landings?" And another fellow says, "The ISS is not the moon. Why the reference?" And so we have to, these folks did not listen to the whole thing, obviously. They just got a piece. We have to go there first. Okay. And I'll go with
Before we get to the moon, let's start with orbit.
Let me go with, let's go back to Napoleon, okay? Here's the $1 million question for you. Can you prove that Napoleon went to Waterloo? Okay, can you prove that?
To whom?
To me, to a conscious person like this. Well, sometimes I'm conscious. Can you prove that? What are you going to put? I mean, are you going to bring the history book and say, well, this is what I studied in high school or college or whatever? Is that what you're going to tell me? That it's in the book? That's like saying, well, the Bible says such and such thing. I mean, so what are we supposed to do? Just to believe what's in a book? Okay? So all I'm saying, you cannot prove that Napoleon went to Waterloo. Even if you went there and filmed it, let's say you time traveled, maybe you were one of those few people who invented the camera in 1815, so you had the camera there, who would believe you? You say, I filmed it. Look, here it is. Here's Napoleon at Waterloo. And, well, let's assume you filmed it. You bring it back, and I say, well, that's a fake. I don't believe you. What are you going to do? You say, that was done in Hollywood. I mean, you can go on and on and on. There's no way to prove that Napoleon went to Waterloo or Caesar went to England or, you know.
The problem there is the word prove, but that's a separate issue.
Well, because proof is belief. That means we accept.
You can prove it to some dudes.
Napoleon went to Waterloo on the basis of belief. We're saying, well, it's been passed through tradition, right, from one generation to the next, and we have no reason to doubt that. But imagine if you had to prove it to an ET. You know, he comes here to the Earth and you say, look, Napoleon went to Waterloo in 1815. And the guy says, prove it. What are you going to do? Well, here's the book. Here's the history book. You know, yeah, okay. So,
but it's like you always say, proof is convincing. Proof is persuasion.
Yeah, I mean, in the Indians used to pass it by word of mouth. We invented writing, and we pass it by writing, but
and we still don't believe it.
Yeah, and so if you cannot prove to me that Napoleon went to Waterloo, let's now put it in the context of the moon landing. Can you prove to me, right, without repeating the occasion, the phenomenon, that Neil Armstrong put his foot on the moon?
Are you a Moonie?
Well, no, but I'm getting. Can you prove to me what happened in 1969? All I can show you, is a movie, a film, right? Maybe some documents, whatever. That's all I can show you. I can try to prove to you through documents, through film, through whatever, through maybe testimony that Neil Armstrong went to the moon. Okay, but I can't reproduce the event again. Okay, and say, look, I'm going to show you that in 1969, Neil Armstrong stepped on the moon. Here's Neil Armstrong, and let me show you how he did it. I can't do that. And so now let's get to where I'm headed. These guys asked, how about the ISS? Well, the ISS is going up there right now, this very moment.
Yeah.
So we're not talking about 1969. So forget about 1969 because I can't prove it to you. And like I say, you can't tell the difference between Hollywood. Let's assume we had all the technology we have today that we had in 1969. Then they could have reproduced anything that you can imagine, like landing on the moon. They could have reproduced it in Hollywood just as well. How can you tell the difference now between the real thing, Armstrong actually stepping on the moon, and these guys doing it in Hollywood? Okay, you can't tell the difference because you won't believe it one way or another because we're already too knowledgeable, too savvy, too intelligent, have too much wisdom on how these things are done. We've also been burned so many times by government, so we have all these conspiracy things in our heads, right? We don't want to believe in anything anymore,
Yeah.
And so the issue is what? The issue is that I can't tell the difference between the real thing and something made in Hollywood anymore. I can't do that.
You're scaring me.
Okay, so if you can't tell the difference, it's not an argument against the fact that we went on the moon. So if Neil Armstrong actually stepped on the moon, you can't say, well, that could have been done in Hollywood.
Whether
yes, of course it could have.
Or not,
that doesn't change the fact that he actually did step on the moon, if he did, right? So you're not going to use that as an argument. Now, another of the arguments some of the people made here is that, look at all the errors. In fact, let me get to some of those, okay? Here's one. Here's a couple, actually. Here's one, okay? And this fellow lists all these things, questions that have to be answered. And he lists all these questions. What materials can withstand the temperature, etc., etc. I think he was referring to the ISS here. But again, he asks all these questions. And I'm saying all you need to do is get a pair of binoculars. Don't ask these questions. Get a pair of binoculars. You have the schedule from NASA. This thing passes around the Earth 15 to 16 times a day, every hour and a half over your skies. If it's not in your region, ask your friend who lives in Illinois or in Germany or wherever to look it up and say, does the ISS pass through there? And the guy will say yes or no. And so if it's a no, he said, no, it didn't pass through here, so it's a hoax. But if he says it's there, well, now you have at least that part. You covered that base. You crossed that T, you dotted that I. But, why ask all these questions? It's much easier to go out there and get one of these, a pair of binoculars and just point it at the sky and see if you can see it. Okay? But here was, I think it's this one here. Give me a second here. Let me look at it. Oh, here it is. Here it is. This is what a lot of people have out there. Okay, a lot of people have their reasoning along these lines. And what this guy says, look, he put all this. He says the Earth is not gray; it is brown. Okay, astronauts hanging off wires. Should have been faster, he says, instead of slow motion. But you would jump higher. And he goes through all these little things that are wrong of what he sees in the movies that are shown, to the world. And the problem I've got here is that, imagine you make a movie of the Romans fighting, in 2,000 years ago. Okay, so here you're the director of the movie, and the guy's fighting with a sword and shield, and he's got a Rolex watch. Well, that's kind of like an error. I think you want to cut that out of your movie, right? And then the scenery is pagodas. Japanese pagoda. So we've got a problem because, that's the wrong scenery.
Sounds like an awesome movie.
So yeah, but then you have so many errors. Do you think the directors, professional people, would have made so many errors?
I mean, they made that many errors in 9/11. You believe it was a conspiracy.
Yeah, but see, they made. But the question, because they did make all these. But see, if you make all these errors, then you say, well, hold it. You mean they made this movie and they had so many errors and none of the directors caught any of this stuff? They were wearing the wrong pants. They were wearing jeans instead of whatever they wore in those days. We've got a problem. So the more errors you find, the less your argument holds. Okay, they could have not made all those errors. Now, if you find one little tiny error and say, "Oh, look, this shadow was wrong," and you just hang on that one, well, that's a different story. But when you say the shadow is wrong, the stars in the background are wrong, the Earth is brown instead of green or whatever.
But isn't that
when you find so many errors, then obviously something is wrong with your reasoning. It couldn't have been so many errors.
But that argument sounds like the fallacy of authority. You're supposing that the directors are competent.
I am supposing that they will not make so many errors. They would have checked all this stuff if they're going to do it.
Shitty directors.
Well, yeah, but again, you got all these experts there, and they say, "Look, we're going to show this to the world. We better do it right." So, okay, so check the lighting here, check the shadows, check the stars in the back. They would have checked everything. And maybe they missed one. That could have been it. It could have happened if they filmed it in Hollywood. But they could have missed so many. If they missed so many, something is wrong with your reasoning. Okay, that's what I'm saying. Okay, here's getting back to the ISS. Again, the ISS is something you can show right now. So forget about the moon landings. If you don't believe in the ISS that's out there, forget about the moon landings. You're not going to believe that one at all. Okay, so let's get to that's why I say the ISS. The ISS is a big monster that is up there. And you can see it with the binoculars. You can tell how big it is. Okay, if you don't know how to calculate that, go to your friendly mathematician. He'll go in there and he'll make all these calculations for you and tell you, look, it's so big, it's so far out. They can do all that stuff. It's got so much mass. Okay, they can do all that stuff. So if you see it out there and you've got all this information, then you say, okay, there is this monster floating out there. It's orbiting around the Earth. How did it get up there? Hopefully, we went through several stages, several steps. And among them, you have to include rockets that take things out into space. Near space, but, it is within, a certain 400 kilometers, that's where it is. But it's something that it had to take several steps to make. You couldn't have, the first stage, just send a couple rockets and send the whole thing up there.
Catapults.
Yeah, in fact, the ISS took 10 years to build, piece by piece.
According to the government.
Right, but see, they had to take it with a shuttle and so on. So if you're going to go through all that, obviously you got to say, well, hold it. They built the shuttle. How did they build the shuttle? They built it from one day to the next. They just took a 747, turned it into a shuttle. Is that how it was? No, they had to go through all these steps where they built one device, then made it more complicated until they eventually reached the ISS, which you can prove is out there floating in the middle of nowhere. Okay? So this is all I'm saying, that this is something you can verify today for yourself without having to wait for the government to feed the hoax, the lie to you. That's all I'm saying.
You're saying-
You can say that men did not land on the moon because you don't trust the government to tell you the truth. Fine, no fake news, you know. But ISS is one of those things you do not have to wait for the government to tell you anything. You can verify for yourself. So if you're concerned about it, if you really want to get to the bottom of it, get a pair of binoculars. We're done. Okay? And so this fellow says the following. He says, watch a 747 at cruise altitude with binoculars, okay? Then observe the ISS with binoculars, okay? Then think about that we are told that the ISS is 408 kilometers away, and it's only approximately double the size of the 747. The 747 is only around 10 kilometers away. In other words, this thing is 40 times farther out. And so here are the measurements, okay, with respect to a football field. You can see the 747 is a little smaller, but there are 747s that grew a little bigger after this. So the length that you see there is not the one for the picture, but it gives you an idea how big some of these 747s are. And they're just about as big as the ISS. Okay, so one is 70 meters, the other one is 73 meters. The wingspan of one is, 68, and the other one is, 109 meters, and so on. So, they're approximately the same, or maybe, the ISS is a little bigger. But they're big, okay? But what's the issue? The issue is here you have the distance, okay? This is what they look like, more or less, okay? The plane on the left is not really at 10,000 meters. That's what I think. But you can see that with your own eyes. You don't need binoculars for that, okay? The one on the right, which is the ISS, that's seen through a telescope, okay? Or maybe, I think it's a telescope in this case. And I showed this other one, which is this amateur, and he filmed it. And here you see his film of the ISS in the sky. This is what it looks like. He's looking at that. He's focused. He's photographing that. In other words, he's filming that through his telescope. Okay, so he's looking through the telescope. That's how he gets that. And you can see the image on the bottom right there. That's what it looks like in the best of cases. So it does look like a monster, but he sees it very lightly. He sees it very blurry. So, you're not comparing, making a fair comparison when you say a 747 versus the ISS. When you're looking at the airplane, you can see it with your own eyes. You practically don't need binoculars. On the ISS, you do need binoculars. You can't see it with your own eyes. Okay, I think maybe someone might see a dot in the sky on a clear day. Could be. I don't know. Have I seen the ISS up there? Any more than I've seen Santa Claus at the North Pole. I have not gone to the North Pole to see if Santa Claus is there, because I don't think I need to verify that specific issue. And likewise, I don't think.
Looking for him.
Well, maybe I can look at him from here. Maybe he's at the North Pole, But likewise, I have no doubt that the ISS is out there, okay? But if you have doubts, well, kill your doubt. Find out if the ISS is out there. That's all you have to do. Okay, here's another fellow, and he says, Buzz Aldrin flipped the torch around in low Earth orbit. He talks about hanging on wires, fake footage, bubbles, underwater training exercise. He's saying that he saw bubbles come out of the suit, and he says that was from underwater, so in other words, that was filmed underwater. They come up with all these ideas, and all I'm saying is, forget about Buzz Aldrin. Do the ISS, okay? And, if you're going to try to show to yourself, right, verify for yourself that the ISS is out there, then you have to explain that. You're going to have to say, how did that thing get up there? How did they put it up there? Did they do it in one day, or were there previous steps? And that'll get you thinking that, we had to have certain rockets before we could send that thing up there, and that'll get you into the program that says, we are sending things out into space, among them satellites. For those who believe in satellites, a lot of flat earthers don't, because they don't want to believe in satellites, because if they believe in satellites, then you can take a picture of the Earth from a satellite and you would show that their flat Earth notion is wrong. So they begin by denying that we have even, satellites out there. But then, how are we communicating? What's this phone that we have that, that collects all this stuff? Is that done through little wires? How are we doing that?
Little people, little fairies in the electronic
Yeah, I
boxes.
mean, these people really go out of their way sometimes. Okay, and again, the guy says, filming the ISS takes almost zero resource and energy, because some people say, well, why don't they have some more films of the ISS and so on? And this fellow says, well, you don't need a big thing there to, like building, when they built the ISS. Imagine what that is. These people are out there trying to build the ISS, and they're going to have just one guy out there, in the middle of nowhere saying, let me film the construction of this, okay? I don't know. Maybe they do have it. Maybe they don't. I have no idea. But I don't think it's a requirement that they would have filmed it. Okay? But some people expect that to have happened, and they say, I don't see any film of them building it, so it never happened. Don't tell me that. Tell me if you have a pair of binoculars, if the thing is up there. That's all you have to tell me. Is it out there or not? Because again, we have people with different levels of belief, of assumptions out there. Some people don't believe any at all. Others say, well, there is this up there, but there's no people in it. Others say, well, there's people in it, but they're not floating around. And so you have all these different levels. So forget about the moon landing. Some people have problems with what is out there already. The moon landing's happened in 1969. Okay, so another fella says... And again, it's if they had a pair of binoculars, they wouldn't say this. But this fellow says that maybe it's a drone. Maybe it's a drone that's up there. He wrote some other stuff in there. Can you tell the difference between a tiny little drone? Maybe it's one of those from Ukraine that got lost in Ukraine war that got lost up there.
Well, even then, it's in space, right?
Yeah, but you're talking about a monster football field size object that is orbiting the Earth at 400 kilometers from here. Okay, so what are we saying? We're saying that
it's a huge drone.
That you can calculate. First verify that it's up there, because if it's not up there, there's nothing to calculate. But once you see it up there, you say, okay, it's so big, it's so distant. You can tell that through telescope. They have all this measurement stuff there that you can verify. And you can say, yeah, this thing is up there. And then all you have to do now is figure out how it got up there. Okay.
Do you have something against the Moonies stuff? Because
putting
everything in the conspiracy pile kind of dilutes real conspiracies? Is that what your problem is against it?
Well, no, this is the issue. The issue
separating the wheat from the chaff as far as conspiracies go. Like some conspiracies are warranted while others are not.
Yeah, there's a couple issues there. One issue is that, intelligence agencies absolutely love conspiracy theories. That's why they pitch so many in there, and they have people even supporting them, because the more theories that are out there, the less people will believe them. They say, well, hold it, this guy believes in this guy believes in that. I don't believe in any of that.
Misinformation.
And so they go with the party line. And they go with the party line for Kennedy's assassination, the 9/11, and Assange, and Ed Snowden. And so, when you put all this together, you say, well, hold it. Are they just pitching more theories in there to confuse people, and so that people will finally get sick of conspiracy theories? Yeah, that is part of the strategy. But I distinguish, Kennedy's assassination, which happened in 1 second. It's like it was gone, right?
Did you see it?
And you got the movie, many years later. Yeah, that's one issue. 9/11 happened in one day. Then the next day, the clean out.
But this was ongoing.
But this one has been going on for years and years and years. You can go to Cape Canaveral, Cape Kennedy, whatever, down there in Florida. Take your telescope and see if that rocket is being thrown into space. Just, monitor it with your telescope and see where it goes. See if it just falls, on the other side of the mountain, or it continues going into space. If it goes into space, then you say, hey, we have the rockets to send them into space. In fact, the Russians, I'm sure, are very much aware that the United States can send rockets all the way to Russia through space, through the Arctic, and vice versa. That's why they have all these ICBMs, and they're worried about all that, because if all that is not true, then you're saying, oh, that never happened, that's not true, that's fake. Well, go to Cape Canaveral and find out if there are any rockets whatsoever next time they have a launch, right? If it goes into space. And you can verify. In fact, they film it, but you don't have to take their film for granted. Take your own film. Make your own film.
It seems like the conspiracy theory that everyone's kind of on now is the COVID stuff.
There's always conspiracy theories about just about every subject, from what is it?
But
climate change and everything.
But it's something that you said as far as the COVID thing also applies here, where when so many countries, which are supposedly enemies, conspire on the same conspiracy, it gets kind of weird. Like, why would they?
Yeah, in the case of COVID, that's my argument, my primary argument against COVID being a conspiracy. You can say that, the United States and Europe got together and they said, let's do this to confuse our people, no problem. But when you have North Korea, Cuba, and, Russia, China, and Vietnam, and all these countries that are, or to some degree Iran, enemies of the United States, and they all agree to fool their own people, and they say, let's all agree. All these countries, what is it, 170, 180 countries in the world, And
but the same thing applies to space travel. Yeah. Why would Russia and the U.S. both conspire to say that we got people on the moon?
Well, they do have that, where I discussed that because someone said, well, Russia and the United States, or Soviet Union in those days, right, and the United States got together and they agreed that they were going to fool the whole world, that they sent probes into space, that Gagarin went around the Earth first man, then Tereshkova, the first woman, Laika, the first dog, And then there was this turtle that they sent also to all the way to the moon, went around the moon and came back. A turtle, that's the first living entity that went through the Van Allen belts and so on. Okay, and so we have all these cases, and then it turns out that it was the Americans that sent the first humans to the moon. And it turns out that the Americans never doubted, never even questioned whether, Gagarin, Tereshkova, Laika went into orbit, and the Russians never questioned that Armstrong was the first man on the moon.
Yeah.
It's like, and you would say, well, is it that they agreed, they were such friends, these two countries, that they decided to, all the politicians on both sides, and astronauts and so on, they all decided that, hey, let's all be on the same page, let's all fool the world. Is that what happened? I doubt it between enemies, but that's what people believe out there, that in secret all these people are not enemies, they're all friends. And here you have Putin, he's killing people in Ukraine. The Americans are feeding the Ukrainian army with the weapons to kill Russians, but all these guys are drinking vodka and champagne, and getting together and having a party while all these people are killing themselves. I don't think so. I think they're true, genuine enemies. But if you believe otherwise, I can't help you. Go to Ukraine and find out, or go to the Kremlin. Anyways, let's open the. I do have some questions here, but do we have any more questions there from? Okay, let me see if we can address some of the questions that some people made that are outside the topics we covered today. And here's the first one. Okay, well, it says, Bill, what does natural and unnatural mean? Okay, essentially he goes going into more detail there. I'm saying that natural is the opposite of artificial. Artificial is what man constructs, or what a beaver constructs. Okay, that's unnatural in the sense that it's secondhand. Mother Nature is using some live entity to build something that she hasn't built directly herself.
Is bee pollination natural or unnatural then?
Yeah, you could say that. Well, it depends on what it's for. If it's just to feed themselves, like they're producing the food, like when we grow our own crops, there you're going to say that it's more like hand in hand. Mother Nature. Weird there. Yeah, I know. It gets very because it gets very fuzzy, because on the one hand you have Mother Nature. She made the seed, the original seed. We modified it. So the modified seed is an artificial seed, but the original seed was from Mother Nature. So what I'm saying is the artificial seed is not natural. We made it. And Mother Nature had no say or secondary say in it. You can say she used us as a conduit, as a mediator to make that seed. And again, like I'm saying, the beaver, same thing. Mother Nature did not make the little house there of wood. It was the beaver who did it, and Mother Nature made the beaver. So it's the beaver who serves as a mediator for that artificial construction, and so on. And you can analyze, bees, wax, and honey. You can go through everything. Is poop from a cow, is that artificial, or is that... Well, I would say that that's natural, because, the cow has no option. The cow has to poop.
Seems like a weird distinction, natural and artificial.
Yeah, all I'm saying is that, if there's a mediator or not. In the case of man, it's a little more clear-cut, because, we make a lot of artificial stuff, especially machinery and so on. When you get into the natural stuff like, seeds and plants, well, now you get into a little grayish area, and you got to analyze it a little more in detail. But when you talk about machines like making robots, making airplanes, hopefully that's not natural. That's why I call, when I talk about life, the definition of life, I'm saying that it's a natural object that moves against gravity, or the path of least resistance. I have to say natural, because we make artificial robots. They move against gravity. They move against the path of least resistance. But Mother Nature did not make the robot. She made us, not the robot. Okay, so that's my take on it. Besides, I don't know what use you would have for any artificial thing calling it life. For example, pixels on a movie screen. Yeah, they move, which is actually lights lighting up. That's all it really is. But let's assume the pixel itself moves. No problem. Is that and you say, well, that's life because it moves against gravity. Yeah, you could say that, but what would be the purpose of including artificial stuff under life? I mean, what's the purpose of that? Is that just to play devil's advocate, or does it have a real purpose? We're trying to define life in a natural way. What does Mother Nature consider life? And I'm saying that the unit is the cell. Okay, it's the first entity that moves against gravity primarily, but you can say against the path of least resistance. Okay, here we have another fellow, and he says the following. He says, there is no energy in matter other than that received from its environment, according to Nikola Tesla. Water doesn't move itself. Water is not life, first of all, and then energy, if Tesla said that energy is received from the environment, then he had no clue, obviously, because energy is a concept, and we do not receive concept from the environment. Okay? So Tesla never had the wording right. That's why he was not a scientist. He was just an inventor. That's all he was. What's an inventor? A guy that does a thing a million times until he gets it right. And Tesla laughed at Edison. He worked for Edison at one time, then he went to work for Westinghouse. And he laughed at Edison because he knew Edison well. He said, look, if Edison had to find a needle in a haystack, he would go through every little straw until he found the needle. And he said, when he could have saved a lot of time just doing some calculations. And he was probably right about that. Edison was not a smart man. He was, in that sense, and not a technician. I think Edison was a good businessman. But Tesla was a better, inventor in that sense. He was a tinkerer. But what is a tinkerer? What is
trial and error.
Trial and error. That's all it is.
He also went through every stick in the haystack.
Yeah, and
finding the right way to build
at AMD and in Intel, where I worked, we did the same thing. It was all trial and error. And I can't say all, because then you have to test it. Okay.
Well, you see a pattern, and then you can skip some trials.
No, and you okay. So because you made some measurements about resistance, you made measurements about voltage, about current, and inductance, and all this other stuff, then you already have an idea. It just helps you zero in on a solution to the problem you have in front of you. But it's still trial and error. That doesn't mean you know what a field is, or what light is, or what electricity is. It doesn't follow that because you work in the industry and you make an assumption that electricity is the flow of particles, meaning electrons from atom to atom. That's actually what's happening there. Okay, in fact, it's not according to our site here. Okay, let me move on here. We have a couple more. Fellow says, putting He's trying to define the word time, and he says, time is change. No. Time is not just change. It's a little more than change. Change is motion. That's what the synonym of motion, change. Change and motion mean the same thing, because you can't have change without motion. Okay? The interval over which change occurs. Okay, that's a little better. The only problem is interval is a synonym of time. So you haven't said anything. You haven't defined the word time. All you're saying is that time is time or interval is interval, whichever way we want to look at it. And something that repeats predictably. Okay, let's find out if that's true. Here we have it. Give me a second here. Okay, here's something that repeats repeatably. This is all that God made. Okay, God only made this ball. Okay, tell me what time it is. No, not to read it out.
Down, up, down.
Yeah, I mean, right now we don't know.
It's up o'clock, it's
yeah,
down
you have
o'clock.
something repeatable, you know, and the only way you're going to be able to determine time if you compare this against another motion. You know, what is time? Well, let's give a specific example. 1 second, which I like to define. Okay, what is 1 second? Well, 1 second originally, not what it is today, but originally it was the motion of the Earth around the sun, and maybe not initially, but you compare it against the second hand on your watch, which moves 1 tick mark, and by the time that hand moves that 1 tick mark, the Earth moved 30 kilometers around the sun. And so you're comparing the motion of the Earth around the sun against that little motion of the second hand on your watch. And so you're comparing two motions. That's what time is. And for that you need memory. You can't have time without memory. Okay? To define it properly. Qualitatively, we have no use for quantitative time in science. That's mathematics only. We have no use for time. Okay, and let me get to the final issue here. I had a couple more. I'm going to have to postpone them for time. And the fellow says, light slows down in a medium. Okay, and where did he get this? Well, here we have 2 prisms on the top, upper right. Okay, in one case we have particles. In the other case we have waves. Okay, and so the fellow says, look, when you have this white light impinging on the prism, what you get out is this rainbow, okay, in both cases. So the question is, can you simulate this with particles? Are we saying that the particles are slowing down when they go through the prism? But when you measure outside on the right-hand side of those 2 prisms, you find that light is still traveling at 300,000 kilometers per second. Almost, you know, I mean, barring air, right, the medium of air. So are we saying that, hold it, the white light traveled at 300,000 kilometers per second. It slowed down when it went through the prism, bouncing against whatever. And then when it comes out, why did it go back to 300,000 kilometers per second? What speeded it up? Where did it get the energy to go fast again? That's the question you have to answer. So you don't have that problem with a rope model, because the rope model is consistent with the equation for light, which is little c, 300,000 kilometers per second, equals frequency times wavelength. Frequency and wavelength are inversely proportional. Okay, so when frequency goes up, wavelength goes down, and vice versa. And the only way you can simulate that equation is with a rope. Okay, because you make the links shorter and you have more links, frequency. And you make the links longer, wavelength, right? And you have fewer links, meaning frequency. So that's what you have. So there is no change in speed of light. Light always travels at the same speed through any medium between any 2 atoms under the rope model. All you have is what you see there, the visible spectrum. What you have is different link lengths, and they determine the different colors, okay, that we see out there. Okay, so when you see colors, what you're seeing is different wavelengths, meaning link lengths, and meaning that the more you stretch the rope, the more the link is stretched, the fewer links you can put in there. Okay, and that's exactly what that equation says. C equals frequency times wavelength. That is the equation of a rope. Okay, so no, light does not travel at different speeds. That's only in mathematics. Why? Because they did it through experiments, and with experiments you're not going to figure out how this universe works.
You're not going to explain anything.
Yeah, you're not going to be able to explain. You have to explain the experiment, the result of the experiment. You can't just say, oh, I measured. Okay, you measured, and what did you measure? Well, you measured coming in 300,000 kilometers per second. Coming out of the prism, 300,000 kilometers per second. But obviously, it broke it down in colors, which means that, what? That you have different wavelengths. Not that you have different speeds. Okay? And the only way you can do that is with a rope. Rope simulates it perfectly. Now, maybe you have a better mechanism. Maybe you have a chain or something else. I don't know. I can't imagine. Angels, whatever you use. But you have to explain that, why that's the case. Okay, and rope can do that, can simulate that. Okay, any other questions? No?
Nope, a lot of comments.
Okay, folks, we'll see you next Sunday. I'm going to be doing this every Sunday from now on, partly due to health issues. I got a lot of work also, and so I'm going to do it once a week from now on. Okay?
Sundays sounds like a religious thing.
Yeah, it's prayer time here.
This is mass.
9 o'clock.
Not physical mass, but church mass.
Okay, we'll see you next Sunday, folks.